Okay, so we're graphing rational expressions. So we've been, with our rational expressions, we've been adding them, subtracting them, multiplying, dividing, and then we solved equations with rational expressions. So now we're graphing them. So let's look at if we just had y equals 1 over x, what that would look like. All right, so I'll go ahead and do y equals, I'm going to clear that out, and I'll do 1 over x. Oops. No. Delete that. Fraction. So I hit enter. And I've got 1 over x. Alright, and we'll look at the graph of that. So that would be like our inverse function. Okay, if you have like y equals, like if something varies inversely. Alright, what happens if I have 1 over x, I get this situation right here at 0, right, where x equals 0, and that is where I have x equals 1, remember y equals 1 over x, so that means my denominator has a 0 in it, and so my function, it goes all the way negative, and then it's going positive here, okay? And this line here at x equals 0, that vertical line, that is called an asymptote, because the function actually never gets to that point. When x equals 0, it's approaching, it goes to negative infinity and positive infinity at the same time, which is impossible. All right, so that is called an asymptote. It's a vertical asymptote because it's going up and down. All right. That happens anytime I'm trying to divide by 0. All right, and that is this here, vertical asymptotes. All right, so if I'm looking here, I've got x equals and x plus 4 in my denominator. So that would equal 0, right? This denominator would equal 0 if x is equal to negative 4. Remember, that was our excluded value. We're saying, okay, x cannot equal negative 4. Because if x equals negative 4, well, negative 4 plus 4 is equal to 0, and I would be dividing by 0, and you can't do that. Okay, so that was our excluded value. So we've been talking about that because that is an asymptote, right? At negative 4, when x is negative 4, 1, 2, 3, 4. All right, that right there, that vertical line, that's my vertical asymptote. And that's a new word. All right, so, and then what happens also is that if I go back and look at that graph, so that's the vertical asymptote, right? My graph, I'm coming along here, and as x is getting, approaches negative infinity, all right, notice as x approaches negative, if I start at 0 and x is approaching negative infinity, it's approaching, my function is actually approaching 0, right? This is where y equals 0. And then again here from the positive direction, if I have x's are positive, and as they get bigger, as they approach positive infinity, I'm approaching 0 here. So this horizontal, this is my horizontal asymptote. So let's erase this so we can actually see what's going on here. So if I start at 0, right, and I head towards negative infinity, notice my function is approaching 0. The line, this is where y equals 0. And then as my x's are approaching positive infinity, right, I'm going to positive infinity, it's also approaching 0. So both lines are approaching 0, but they never actually get to 0. Okay, because you never actually get to infinity. It just keeps getting smaller and smaller and smaller. It approaches zero, but it doesn't actually get there. It's a limit. So that would be my horizontal asymptote. And that's would normally be at zero, but now I have this plus 3. All right, so it raised it up 3. 1, 2, 3. It's just like all our regular functions, right? What is sticking out here is going to make it go up and down, right? And because normally it would have been at 0, 0, where my asymptotes intersected, but now it went up 3, and then this is going to make it go left and right, right? This one's up and down, and if it's sticking out, and if it's with the x, right, that's going to be a horizontal shift, so that made it go to the left 4. All right, so I went to the left 4, okay, and then I went up 3. Okay, left 4, and then up 3. Went up 3. Okay, so that was my new center, because the center went from, it was originally at 0, 0. If I look at just 1 over x, right? If I look at just 1 over x, that graph, all right, where they intersect, there's my horizontal asymptote, and here's my vertical asymptote. And where they intersect is at 0, 0. Okay, like before, we kind of move around the vertex. Well, here you're moving around this kind of bullseye. So this is going to go left and then up, and so it moved over here. And so that was my new horizontal and my new vertical. All right? And that has to do with the vertical asymptotes. All right, your vertical asymptotes are when your denominator equals 0. Okay, because you cannot equal 0. The denominator cannot equal 0. All right, so the vertical asymptotes, those are your excluded values. Okay. The horizontal asymptote is what is happening as x goes to positive infinity, all right, and as x goes to negative infinity. All right, that's the horizontal asymptote, as x gets really big or really small. All right, horizontal asymptote has to do with end behavior. Okay. So vertical asymptote has to do with the denominator, can't be 0. Horizontal asymptote is your end behavior. Okay. And then you have your transformations, right, where you move left and right and up and down. And then you can also reflect, too. That negative in front, all right, that's still a reflection, just like before. Okay. So let's go ahead and look at that original one again, too. If I'm looking at the domain and range, right? If I'm looking at the domain here, all right, well, can x be anything? Well, it's all real, except what? Except 0. X cannot equal 0, right? X cannot equal 0. So all real except 0. If I write that with my interval notation, that would be I'm going from negative infinity to 0, and then from 0 to positive infinity. Okay, and that's my domain. As far as the range, all right, if we're looking at the range, looking at the y values, All right, looking at my range. Well, my y's, it goes down forever and then it goes up forever, right? But this horizontal asymptote, all right, remember range is the y's. Y's cannot equal 0, okay? So it's all the reals except 0 for the y's, okay? Or again, going from negative infinity to 0 and from 0 to positive infinity, if I'm using the set notation. I should write that here. Okay. So now if I look over here at what's happening, I'll go ahead and put this into the calculator. And then this is actually, remember this reflection is across the x-axis. Okay, so it normally looks like right, 1 over, they're normally negative like that. Okay, that's my normal one. So if I reflect it across the x-axis, then things are going to go up like that, and these would be like that. Okay, so the green is my reflection. This would be reflection. Okay, so let's put this into the calculator and see what it looks like. That's the beauty of the graphing questions. All you have to do is put it in the calculator and see what happens, right? So we've got, that would be our parent function, right? 1 over x, okay? Now I'm going to go ahead and put in minus, so I'm thinking that that's going to reflect it. And then now I've got a fraction, so I hit enter here. And I've got 1 over x plus 4, so x plus 4. All right, and I'm thinking that's going to move it horizontally, which is always the opposite, so I'm thinking it's going to go left 4. And then this is going to move it vertically. This will make it go up. Okay, and when I say it, I'm talking about the intersection of those asymptotes, the vertical and the horizontal asymptotes. All right, so look at the graph. And sure enough, it is reflected because it's going, the negatives now are positive, right? The negative x's are positive. All right, so there's my reflection. And then here is my vertical asymptote, right? That's my vertical asymptote is at x equals negative 4, okay? And my horizontal asymptote is at y equals positive 3, okay? And it's, again, it's reflected. All right, now if I'm looking at the domain and range, right, so it's reflected, so it's looking like that. All right, now if I'm looking at the domain and range, I'm going to say, okay, the domain, right, is the x's. Okay, well, my x's are all reals except for 4, so I'm going to go from negative infinity to negative 4. Let me write that there, just right for 4. So the domain is going to go from negative infinity to negative 4, right? And then it goes from negative 4 to positive infinity, okay? All reals, but x is not equal to negative 4, okay? That's my domain. And then my range, okay, looking at the range of that, I'm looking at range is always the y's. So I'm going to say, okay, my range is going to be from, right, looking up and down for the range, all right? So for the range, it's, again, I'm going from negative infinity, but what's the asymptote? It's when y is at 3 to positive 3, and then from positive 3 to positive infinity. All right, so it goes here, but then it stops at 3, and then it picks up and it goes up to infinity. Okay, so the range is also all reals, but y is not equal to positive 3. Okay. And then the last word there, the last question was about holes. And there's no holes here because we didn't, a hole would be where you have a factor in your numerator and your denominator. So we don't have any holes there. All right. So, all right. So very good. So we have domain range. The end behavior kind of is taken care of with our horizontal asymptote. All right. It's going towards, the end behavior is it's going towards 3. Right? End behavior is y approaches 3. Y approaches 3. That's our horizontal asymptote. Okay, so there's a lot we can say about every single graph, and basically that's what we're going to do for each one, is just look at these transformations, and we've been doing this since September, so, and you guys are getting better and better at identifying these transformations and the ranges, etc. Okay, so let's look at another one. All right, let's look at 3. Okay, and again, I have the parent function is just the simplest form of this, right? If I take out all the numbers and I've just got a y and an x, that's my parent function. Okay, which is, notice it's similar to an inverse variation, right? It's just that if like that's a k, right? If that was a number, other than 1, actually 1. So it's similar to an inverse variation, just leave it like that. Okay, so, and then now I've got these same things coming here. So if I look at the parent function, then, you know, my horizontal asymptote would be that at 0, and my vertical asymptote would be at 0, 0. Okay, that's for my parent function. All right, and then now, though, I've got these transformations going on here. I've got reflection, right? And then a 3 here, so that's multiplied, so that would be a stretch, right? So I have a reflection, a stretch, and then a horizontal, right? It's going to go, but it looks like it's the opposite, so instead of left 1, it's going to go right 1. That's what I'm predicting. So we want to predict before we put it in to the calculator. That way we learn more, right? And so let me go y equals, and so I've got, this is also negative, but now my numerator here is 3, so I'm thinking that'll be a bit of a stretch. And then my horizontal transformation is -1, so I'm thinking it's going to go to the right. And there is no vertical, so I'm going to delete that. It looks like it would be, so it's still going to be my horizontal asymptote at 0. All right, so if I graph that, okay, so it moved over to the right 1. Okay, I can see my vertical asymptote, right? My vertical asymptote is x equals 1, positive 1. All right, my horizontal asymptote is right here, right? The horizontal asymptote is at y equals 0. Okay, and then it is reflected, right? It's reflected because my negatives, right, are positive, and my positives now are negative. All right, so that was a reflection. Okay, across the x-axis. If I wanted to look at some points, all right, if I want to check out and make a really accurate graph, I'll go ahead. Actually, while I'm there, I'm going to go to the table. Oh, and I could actually see it here anyway. -5, 4, and -3, 2. So 1, 2, 3, 4, 5, 1, 2, 3, 4, right, negative 3, 1, 2. Oops. Let's see if that's right. Right, negative 5, 4, negative 3, 2, there's some other points that I have. Right, yeah, no. Negative 2, 1. Right, negative 2, 1. Right, see how these are getting closer and closer to 0? Right, all these are less than 1. All these numbers, as I approach negative infinity, I'm just getting closer and closer to 0. All right, so I'm going to stop. Okay, and as I approach 0, right, as I approach 0, or no, what was my vertical asymptote? 1, right? So as I approach 1, there's where my error is. Oops. I get to 1, right? There's the error. That's where I'm trying to divide by 0. So this tells you where your asymptote is, right? When x equals 1. There's an error because we're trying to divide by 0. And to the left of that, I've got 0, 3. And then to the right, I've got 2, negative 3. So I have 0, 3. All right, so here's this point up like that. And then to the right, I have 2, negative 3. So I have 2, 1, 2, and then negative 3. All right, and then again, as x gets bigger, if we look at our x is getting bigger. Oops, oh, I'm going to the right one, I'm going to the right. As x is getting bigger, notice I'm approaching 0, but from the negative, they're all negative numbers, just below 0. Okay, so as x gets bigger, I'm approaching 0. Okay, and as I approach negative, where's my vertical asymptote? Here's my vertical asymptote. All right, there's my vertical asymptote. Is at x equals positive 1. Okay, and then it's approach, as I get closer to that, I'm getting smaller. I'm going to negative infinity. Okay. So this is my horizontal asymptote. It's approaching y equals 0, right? As I go, as x approaches positive infinity, all right, y is approaching 0. Okay, as I go positive, and then as I go to negative infinity, as x approaches negative infinity, y is approaching, it's also approaching 0. Okay, both over here too, it's getting smaller and smaller and smaller, but it's never going to get to 0. Okay, so your horizontal behavior is asymptote, so if you look at the end behavior. And then my vertical asymptote is when I look at my excluded values, right? Denominator cannot equal 0. All right. And there's no holes, again, because I don't have the same factor on top and bottom. So we'll get to that. We'll talk about a hole when we get there. Okay. So let's look at the next one. Okay, it's the same thing. So while we're here, we'll just graph it. We'll just put it in the calculator. Alright, so this is number, we'll just do the odds, and then you can do the evens on your own. So for number 5, there's no reflection, right? It's not negative, so I'm going to delete that. Okay, no reflection. There is a stretch, but it's only 2. And there is a horizontal, and it's again 1 to the right. So I'll leave that there. And then now there's a vertical transformation of +1. Okay, so it is going to the right and then up 1. So let's look at that graph. Okay. So I can see here is my, and move, instead of being at 0, 0, my vertical asymptote, right? My vertical asymptote is x equals 1. And then my horizontal asymptote, all right, my horizontal asymptote is y equals 1. So I went to the right 1 and up 1. Okay. So let's draw that in. So I went to the right 1, right, and then up 1. Alright, that's my horizontal asymptote. And vertical asymptote. Alright, that's the vertical asymptote. Alright, went to the right 1 and up 1. Those are your transformations. Right 1, up 1. Right, those are transformations. Okay, and then if x is negative, as I go to negative infinity, right, I'm approaching +1, and as I approach my asymptote, it goes negative. All right, and then here, as I approach positive infinity, I'm approaching 0, right? As x gets bigger and bigger and bigger, my denominator is getting bigger and bigger, so I'm dividing by a bigger number, so I'm approaching this 1 here. And then as I approach the asymptote, it goes up like that. Okay? And then the 2 makes it a stretch. Anything more we can say about that? Yes. So we have our horizontal asymptote is y equals 1, right? So what that means is as x approaches positive infinity, y is approaching 1. And as x approaches negative infinity, y approaches 1. Okay? Horizontal asymptote, as you go left and right, as you get bigger. Okay, you're approaching 1. And what was it? Oh, vertical, right? My vertical asymptote, x cannot equal, my vertical asymptote is x equals 1, right? Because if x is 1, 1 minus 1 is equal to 0, and I'm trying to divide by 0. Okay, so my vertical asymptote is x equals 1. So if I'm looking at my domain, right, I'm going to write the domain here. Well, the domain, all my x values, I go from negative infinity, right, because it goes here forever to the left. But when I hit 1, there's trouble, right? When x equals 1, it's not included. But then it picks up again at 1 and goes to positive infinity. So that's my domain. Right, looking at the axis. And then for my range, I'm going to look at the y values, okay, which are also, right, my asymptote here is also 1. So the range is going to go from negative infinity to 1, and from 1 to positive infinity. Right, the range, it goes from negative infinity, right, to 1, and then it picks up at 1 and goes to positive infinity. So that's the range. Like I said, there's no holes because I don't have a same factor on top and bottom. All right, very good. So we'll just keep practicing this, and you're going to have these transformations down. So we'll say 7. Again, you've got a stretch, right? So you have a stretch of 3. Okay, and then it's going to go, there's a -1, x -1, so it's going to go to the right 1, and then this is going to make it go up 1. Okay, and when we're talking about that, we're talking about the asymptotes. Alright, so my asymptotes did start at 0, 0, alright, but I'm thinking that it's going to go right 1 for my right, because if x equals 1, that makes my denominator 0. So there's my vertical asymptote, where that excluded value is, right? The vertical asymptote is x equals 1. Right? Remember, that's the equation. X equals something is the equation of a vertical line. Right? Remember, that was our lux. Vertical line is undefined, and it's x. Right? And then now I have a horizontal line here. 1, it went up 1. So here's my horizontal asymptote. All right, my horizontal asymptote is y equals 1. All right, that's my void. All right, horizontal, 0 slope, and it's a y. Okay. And then now if I want to graph and get the exact points, I'll look at the table. So I'll go ahead and put this in. I'll always check, make sure you've got it right by putting in the equation. Okay, so we're looking at number 5. So that was a stretch of 2. Oh wait, no, we're at number 7. So it's a stretch of 3, so make that be 3. And we haven't been really focusing on the exact points, so you can't really tell with the stretch. So let's look at the points so we can tell that it's actually steeper. Remember, stretch makes it steeper. So you have a steeper slope. Let me graph that. Alright, so we can see that we're right. It was to the right 1 and up 1, okay, for our horizontal and vertical. And then for the steepness, alright, for the stretch, we have to actually look at the table and get some points. So I'm going to look at close to the asymptote is where you're going to get your values. So 4, 2, and 2, 4. Alright, so I have 1, 2, 3, 4, 1, 2, and 2, 1, 2, 3, 4. Alright. So there's that. And then on the other side, I'm going to see it similar thing. So let's look at, there's my asymptote, right, where there's an error because you cannot divide by 0. So I have 0, -2, and -2, 0. So 0, -2, 0, -2, and -2, 0. So I'll connect these so I have get my full graph points. Right? To get your graph points, you have to have actual points that are on the graphed. Okay. Oh, domain and range, right? So domain is going to be -infinity, right? Domain goes from -infinity to this vertical asymptote to 1. And then it goes from 1 to positive infinity. So once we've done a couple of these, that doesn't seem so bad. So range is, you're looking at the y values. So range is the same thing, but it's going to go to what happens to also be positive 1. So -infinity to 1, and 1 to positive infinity for the range. So domain range, and again, no holes because there's no common factors that we've divided out. Okay, so you can go ahead and do 9. I would think we've practiced those a lot. Let's find one that is different. All right, I'll expect you to do the ones that are the same. All right, that are similar. Practice makes perfect. That's how you learn how to do this. All right. So now these are a little different if you have to factor. All right. So let's see what happens here. I have x plus 1 in my numerator, and then I have negative 4x minus 12. So what I'm going to do is I'm going to look at my, I'm going to factor this denominator. So I'm going to do my GCD, right, between 4 and 12. I do math num 9. So math num 9. Oh, I need to get, you know what? Well, I'll go ahead and do math num 9. So I'm going to quit out of this. So math num 9. All right, and what was it? 4 and 12? 4, comma, 12. Okay, enter. So 4 is the common factor that I can divide out. Okay, and then I'm also going to divide out a negative. All right, I'm going to divide out a negative so I can get my constant there. So that would be negative 4, and then that divides out, so I have x, and then that would be negative divided by negative, so that would be plus 3. Okay, so what that turns out to be is x plus 1 over negative 4 times x plus 3. Okay, so what are my excluded values? Well, in my denominator, this is going to cause trouble, right? So x cannot equal negative 3, right? Because that's a positive 3. So x cannot be negative 3. So that would be a vertical asymptote. All right, remember, your excluded values are your vertical asymptote. So x equals negative 3 is my vertical asymptote. So 1, 2, 3. So there is my vertical asymptote. All right, x equals negative 3. And then now I'm looking at up and down, right? And there's nothing sticking out here, up and down. There is this negative, so it looks like it would be possibly reflected. All right, so let's see what is going to happen with this graph. Because I have this numerator. We haven't had an x factor in the numerator before, so let's see what happens. Oh, okay, the y equals. Quit. Oh, that's there. And then go to y equals. And now what I've got is and I factor out. I factored out. We have x plus 1 in the numerator and negative 4. Alright, so x plus 1, oops, there. Alpha y equals, enter. I've got x plus 1 in the numerator, and then in the denominator we had negative 4, and then we're factoring out that was x plus 3. Okay, so let's graph this and see what happens here. Okay, so it looks like a regular old, you know, that inverse graph, right? I've got, and it is, here's my, at 1, 2, 3, there's my vertical asymptote, just like we expected. All right. But it seems to, let's look at the graph, let's look at the table and see what happens to our y values. So there's our asymptote, right? X equals negative 3. All right. So I've got, I can graph at -1, 0, right? -1, 0. Do I have another integer? No. Alright, so I have -1, 0. -1, 0. Alright, so it definitely crosses there, right? So is my y asymptote, is my horizontal asymptote 0? No. Right? As x goes to infinity, you know, there's a point there at 0. Alright, so the horizontal asymptote can't be that. Alright, so the question is, well, what value is this approaching? Alright, so let's see, what value are all these numbers as x gets bigger and bigger? What value are these numbers approaching? So, and it's hard to tell because I can't see the whole number. Oh, well, here's one that is 9/37, all right? 9/37. Remember, it never gets to this value that it's approaching, all right? What is 9/37 close to? Well, 9/37 is close to 9/36, right? So let's check and see what that is. What is 9/36? 9/, oops, I don't want to do that. 9/36. Oh, 1/4. All right, so it seems to be approaching 1/4. So, and we know that because it did cross, right? It crossed 0, all right? But it did seem very close to 0, all right? If we look at that graph, oops. If we look at the graph again, right, it's, it's reflected, isn't it? It's reflected because of that negative sign, right? It's reflected, right? So it's actually going down like this. What was that? 0, no, -1, 0, right? So it comes down here, but it seems to level off, right? If we look at this, right, it's coming down. So here's my vertical asymptote, -3. And then so it's coming down, it's approaching 0, but it actually hits 0, and then it comes down here. And it seems to be at -1/4. It's approaching -1/4 for my vertical and my horizontal asymptote. Y equals -1/4. Okay. So notice if x is going to be 1,000,000, right? We're going to have x is 1,000,000, and we just look at this original problem here, right? If x is 1,000,000, so that would be 1,000,000 zillion, right, plus 1, right? And then this is, and you've got one of those, right? 1,000,000 plus 1. And then here I have -4 times 1,000,000, right? I should count my zeros, but there's 1,000,000, really big number, zillion, minus 12. Well, if you've got 1,000,000, these don't really matter, okay? Plus, if you've got 1,000,001, 1,000,000, 12 less than that, they're basically 1,000,000, right? So basically, this crosses out, okay? You've got 1,000,000 over 1,000,000, right? 1,000,000 zillion over 1,000,000 zillion is 1, okay? Not exactly, but remember we're talking about x is approaching positive infinity. X is getting really, really big. Okay, so we're not talking about what that it's ever going to get there, but y is definitely approaching -1/4. And notice that happens to be the coefficients there. right? So if your exponents here, if you have x divided by x, all right, your horizontal asymptote is going to be the coefficients here, all right, because these just divide out, okay? And then I would look at over here, it's approaching, again, negative 1/4, all right, but it would be down here, right? It's reflected. Those would be my points. Just look at the graph one more time. All right, so you have it over here. And if I looked at my table, well, my numbers are really big, so I'm not going to find it, but I'll just leave it and look at the graph. Okay. So that is the main point from that we're going to get out of this. Okay, we have the vertical asymptotes, and then notice your horizontal asymptote. If you have numbers, variables on the top and bottom, if they're the same exponent, then they cross out, and your coefficients are your horizontal asymptote. Okay, that's if they're equal. And then here we have, that's as it goes to x, it goes to positive infinity, and as x goes to negative infinity, y also goes to negative 1/4. Right? As x goes to negative infinity, it's approaching that negative 1/4. So here is my horizontal asymptote. All right, y equals negative 1/4. So now if we look at number 10, oh, this has gotten really long. So I'm going to stop, all right, and then we'll pick up with number 10.